Hello, hello, gorgeous people. Let's do problem number 4. I have misplaced my pen. Ah, there it is. Okay, let's do problem 4. So problem 4 says it's quite short. Given a string in Roman numeral format, your task is converted to an integer. Um, So let me write. So I pre-populated this list with this problem with some things because it's definitely going to be quicker if I do this part first instead of having to write it out or type it out. But it also kind of gives away what direction I'm heading in because I did do a similar problem for free co-camps project algorithm challenge thing. So it's not like a totally brand new thing to me, but the free co-camp one was to convert an integer to Roman numerals, whereas this one is Roman numerals to integer, so that's different. But and I think the free co-camp one's a lot more complicated, or I thought it was when I was doing it. Really, really tricky, or really like, I don't know, it was hard. This one is, I think, a little easier for me to understand, so thank goodness, because the other one was really hard. So yeah, we are doing very important Roman to int. Oh wait, my dog's barking. Okay, hi, I'm back. Sorry about that. Oh dear. What was I doing? Sorry, we were babysitting a neighbor friend's dog. So I don't know where I am at all. Um, we're doing problem number 4, Roman to int. I think I spelled integer and just midway gave up. Integer. Okay, I think I remember now. All I'm doing is just writing the title. Okay. Like what? Uh, let's see. Okay, so I pre-populated this dictionary with inputs to make it easier, and we're going to initialize the. This is I don't know. I just wrote this. Okay. Um. So what does it say? Yeah. Given a string in a Roman numeral format, your task is converted to an integer. So if so the example we were given. So Roman numerals are these letters, English letters that represent numbers, and that's how they did math back then, I guess. I don't know, but yeah. So like the input, if the input was V, the output, the desired output would be 5. Because if you look at V in the dictionary right here, the value is 5. And that's what it means in Roman numerals. And if it was like 3, like this, these are I's, so 3 of these, then it would be 3, not 1, 3. So yeah, those are Roman numerals. Another example I could give, oh, what did I do? Oh, I wrote that first. Okay. You know, I'm just gonna do this. So, not to be confusing or anything, but like, let's say we're trying to write 998. I don't actually know how to write that. So let's say we want our output to be 998. That means that we need to I think there's an M in there, right? Let me just figure out how to write 998. Yeah, okay. So yes, there would be a M in there. in the second one because oh my goodness. Sorry, I shouldn't have chosen such a difficult number to write. The input would be, so there's an M in there because this is the closest, and then there's a C because we're subtracting C, and then the rest is just like if we were to write 98, because this one would equal out to 900, and then we would need 98s here. So 98 would be the same concept where we take 100, which is C, and divide it by 10, and then writing 8s would be 5, 1, 2, 3, like we demonstrated before. So this part is 8, and this is actually 90. So that would make, let me do it that way, that's smarter. So yes, my loves. That would be 90, that's 900, that's 8, and you add it together, that's 998. So that's what we're trying to do, using this dictionary. And how Roman numerals work is that if you want a 900, you would have to get this M and then put a C in front of it, and that's how you get 900. The same with this C. You get the C and then you get the X in front of it, and that's how you subtract it. If it comes after, like the 8, then we're going to start with this, and then we're going to add 1, 2, 3, and then it becomes 8. Does that make sense? So our code, that's how Roman numerals work. I didn't even know that, actually. But that's how Roman numerals work. And then now we're going to try to code that exact scenario up, and it's actually a relatively simple code. I think the key here is to work backwards. Well, the key here is to use a map or a dictionary and work backwards. So we're gonna write another way is you could literally just, like, in the dictionary you could write, like the values. Like if you wanted to write 40, you wanted to code in 40, and it would just be XL, and it would be 40. You could do that for every single one of these, and that'll make it easier to compute big numbers. And it would also, I think, make the time complexity better, because it would just be a direct lookup. So it would be, if we did that, it would be a constant time. Whereas this method, I think, is linear time. So the method I'm going to do, but then it's also tedious to have to write every single symbol. So it really depends on like what your goal is, I guess. Like if because this takes more space, which doesn't really matter, but it also takes longer, like more manpower to I shouldn't have. Well, anyways, so yeah, I just wanted to mention that. So yeah, let me erase this also because it's kind of ugly. But yes, this is oven time, and space-wise, yes, we have to create a hash map. But I was told that that's actually in the hash map itself. If you just do it like this, it's not very big. Am I recording? Oh my god, did I forget? Okay, good. It's not very big, so it's still going to be, I believe, it's not going to be end time. It's going to be like linear, not linear. It's going to be constant time for the space. So yeah, so yeah. So I don't see why we can't just, write it up. Because in the end, this is essentially, just, I don't know, writing up how Roman numerals work. It's kind of annoying too, because, I don't know, I struggle with the coding aspect of this, as per usual. But yes, the method is, I'm just gonna write, there's probably another method to this, but yes, let's just get it over with. I need more space on my workstation. What's going on with my phone? Give me a second. I'm just trying to finish this problem. Okay. So we have a variable called Roman. We have a dictionary called Roman map, and that's what we're using to look up. And we have the answer is currently set to 0 because we need to have a starting point and kind of like a neutral starting point. So actually, yeah, answer to 0. So we're gonna return our answer, and it will be in integer form. So so 4. Wait, how do I? No, that's not it. Define Roman int, and then we're gonna have input string, and I think that's it. Yep. And okay. Yeah, we just have the string, and then we have the dictionary. So pretend like the dictionary is here. Where Roman map is the dictionary. So we're gonna go in the code and pretend like this. Just pretend like this whole entire part is essentially here. Okay, cool. So I'm gonna do a for loop, and we're going to go and iterate through each. We need the index because we need to be able to peek ahead to compensate for the cases where we're subtracting instead of just adding. Adding is easy, you know, like we could yeah, we could just sum it up. We could look it up on the table, map, dictionary, whatever they're called. We could look it up in the dictionary and just go, okay, add it and add it. But then for subtraction, we need to make sure we recognize the characteristics of subtraction. So we need to be able to peek ahead for that. So for I in the index of string, we're going to go if I plus 1 is less than the length of the string. So basically we're looking for if there's anything in front of it, and the value at the index that we are looking at I, and I changes, is smaller, because if it's smaller, then we know by the laws of like Roman numerals that it's a subtraction. So S and then I plus 1. Wow, that was, yeah. So this is where we peek ahead to see if it's less than, and if it is, then we go, well, the answer is whatever minus that Roman index is. So whatever I is would be subtracted by the whatever the answer is subtracted by the I, and then else the well, else is easy. It's just if you're not subtracting it, then you're adding to it. So it's just plus equals Roman as we move forward. So yeah, that's about it. That's really the entire code. Oh, and then we have to return the answer. And this happens after we have finished the we have reached the end of the I, or end of the end of the index. So there's nothing to peek ahead. Okay, so I spent some time running through real quick. I have to go in like 5 minutes, but basically I'm gonna, so this is the input I had, 998, So if I already wrote it, but if we run through the first index, which is C, and the C's value is 100, we are going to subtract answer initialized as 0 to 100, which makes 0 minus 100 right here is negative 100. Yeah, and then we're going to add for M a hundred, which is worth 1,000. We're gonna, it doesn't match any of this, so we're gonna do this one, and uh, 1,000 plus negative 100 is 900, so we end up with 900, and we do the same thing for this going forward with each index, and then finally, after doing all this math and these conditionals, we will get 998. So yeah, hopefully that makes sense. That's how I took it as, and I was like, yeah, it's you, because your brain has to kind of go with the eye and have faith in the iterations and stuff. Because at first it seems really unintuitive, because you're like, oh, but you know, but yeah, all these conditions need to be met, and that's what this very important line here is. So yeah, okay, cool. Bye. I think that's about it. I did mention linear time and constant space. Okay, bye. That's problem 5. Cool. Or that's problem 4. Okay, I gotta go. Hee hee hee.